Hi, my name is Sanit. My student ID is 11555858. I have done my research on estimating floating point errors using automatic differentiation. First, we need to know about the FP errors. FP errors are generally is the minimization of errors caused by the fact that the real numbers cannot, in general, be accurately represented in a fixed space. In other words, it can be said that FP errors cannot be eliminated, but only can be managed. So if you get to the introduction part, floating errors can have severe implications for program with high precision calculations or simple but repetitive computations, as I have said earlier. Floating point stability is important for data intensive science work with increasing data volume and often in heterogeneous computing environments. For example, float versus double can make a large difference in performance, as many GPUs either do not provide double precision float, do not follow the IEEE compliance, or have fairly low accesses. So it is very much required as the FP errors elimination. Robust and atomized detection of FP errors can help reduce the data reprocessing costs and foster development new lossy compression algorithms. So, like if we before we going to the approaches to tackle this, we need to know about the background of it. Usually there used to be like a floating point representation and algorithmic differentiation in the back. So floating point representation has become the primary implementation of a real valued arithmetic on digital computing platforms, although it is well known weaknesses, that example for example like rounding errors and cancellations. So within a size fixed size feed build bit field, there are three parts: the sign bit, a biased exponent, and a fractional part, sometimes called the significant or mantissa, with an implicit leading digit. Rounding errors occurs when a real number with finite possibilities is approximated with a finite number of bits in a floating point format. And if you come to the algorithmic differentiation, also known as the automatic differentiation, is a chain rule based technique to evaluate numerically the derivative of a function specified as a computer program. So there are three methods in computing the derivatives, include hand coding the derivative, symbolic differentiation, and numerical differentiation. Now, if we get on to our approach to estimating FP errors, there are multiple ways in order to approach the floating point errors. Most common one is the Taylor series. So given is an expression where h represents the upper bound on the floating point error of x. An absolute error due to floating point limitations in a function can be expressed using a Taylor series. And the other approach that can is the algorithmic differentiation evaluates the exact derivative of a function. There are two modes of automatic differentiations. First one is the forward automatic differentiation, and the second one is the reverse automatic differentiation. In the forward mode, it divides the expression into a sequence of differential elementary operations. The chain rule and well-known differentiation rules are then applied to each elementary operation. When it comes to the reverse mode, automatic differentiation uses an extension of the forward one, like it is done similarly to the forward mode, but to enable the computation of a gradient by a traversal of a graph. As the software runs the code to compute the function and its derivative, it records operations in a data structure called a trace. So these are the two methods, two modes of automatic differentiation. Now, if we come to the conclusion, as I have said earlier, FP errors cannot be eliminated but can only be managed. But AD-based FP errors analysis enables understanding the largest contribution to FP errors and enables mixed precision program optimization. An AD tool is implemented in the compiler, such as CLAD, provides opportunities beyond computing derivatives. Other considerations which we have not discussed here include a package ability capacity to handle more advanced computational features such as parallelization and GPU. Here I want to end my presentation with the references which I have prepared my presentation and the research paper. Thank you.